Good morning, students. This is Balamurali, Assistant Professor, Department of Computer Science from St. Joseph Institute of Technology. And then today we are going to discuss about IP address. So before that, we should know about what is the objective of IP address and what is the purpose of IP address and why we want to study about this IP address. So these things we want to know it. Then only we will understand about all the basic topics and all. Okay. So just at the end of this session, finally each and every student they will know about objective of IP address and what is the types of IP address and subnet masking and subnet related problems and differences of IP address and MAC address, and finally we'll know about all the IP related problems. So this is the overall agenda of today's sessions. So now we'll discuss about overall definition of IP address. So the IP address, the expand of IP address is Internet Protocol. So where we are using this Internet Protocol in your computer network. So what is the main purpose? First, before that I will tell the one real-time example. So one student is there in one particular college. In that particular college, we are having so many number of students is there. Okay, so we don't know about, if you are calling to that persons, we don't know about that name and all. Okay, so then in department itself what they are going to do means some particular register number is going to give to the students. Okay, so that same real time example also we are using here. Here in particular network we are using multiple number of devices. We don't know about that IP address and all. So in that particular address systems we need what is the IP address for that systems and everything we should not know about this all the things. So what we are going to do means separately we are giving some IP numbers. Okay, so that IP numbers is called an IP address, and then in this IP address they are having multiple number of types is there, class A, B, C, like that so many types is available. So each and every IP address they are having separate ranges, and each and IP address they are having separate partitions. So everything we are going to discuss one by one. So first I will explain about what is the main objective of IP address. The main objective of IP address, for example, if you are going to connect one new device in your particular network, so if you want to communicate that message to in that particular network, you require that IP number. So after that only you are going to connect that network, after that only you are going to communicate the networks. So that is called an IP address. So that is the main objective of IP address. With using IP address, you are going to connect a particular network. Then only you are going to communicate the messages. If you want to communicate that messages with the help of MAC address only, you are going to communicate the messages. So this is the main differences of IP and MAC. Okay, IP address means that one is the temporary address. When you are going to change the network, in that time IP address also will going to change. But MAC address is a unique address. Without MAC address you are not going to communicate the messages. But IP address is a temporary address. Depend upon the network, IP address is also going to change it. So first I will explain about what are the types of IP address. So totally we are having 5 types of classes it's there in your IP addresses. So one by one I will explain. So class A, class B, class C, class D and class E. So these are the 5 types of classes: class A, class B, class C, class D and class E. So for class A, this class A they are having separate ranges, which means for example 0 to 191. So this is the ranges of class A. In between this 0 to 191, how many devices is there? That is the total number of class A ranges devices. Here each and every classes they are having separate partition. For example, each and every classes they are having separate partition means all the classes they are having 4 partition. For example, 0, 0, 0, 0. So this is the 4 partitions. So each partitions they were having 8 bits. So this is the 4 partitions. So each and every partitions they were having 4 bits. Sorry, 8 bits. This one is 8 bit, and this one is the 8 bit, and this one is the 8 bit. Okay, 8 bit means 8 bit number of zeros it's available. If you are giving any binary decimal numbers, that will convert it to the binary number. That one is the common example. In each and every systems they are knowing only the binary numbers. So for example, if you are giving 0 means totally 8 bit number of zeros it will take. At the same time here also 8 bit number of zeros it will take. Here also 8 bit number of zeros it will take. Here also that same procedure. So totally we are having 32 bits. Okay, so IP address total range is a 32 bits. So this one is the 0 to 191 ranges. Okay, then after that class B ranges is 192 to 223, and next one is the class C ranges 224 to 233, 234 to 239. So these are the 5 types of classes. Each and every type they are having separate ranges. So I will explain about each and every class types. Okay, so class A they are having ranges up to 0 to 127, and class B 128 to 191. This is the ranges. And class C 192 to 223, class D 224 to 239, and class E 240 to 255. This is the overall ranges of each and every classes. So previous itself I explained each and every classes they are having separate ranges. So for example they are having 4 partition first of all. So 0 0 0 0. So this is the 4 partitions. So each partitions they were having 8 bit ranges. 8 bit. This is also 8 bit ranges. So this is also 8 bit ranges. For example, so already I explained, so 0 to 127 ranges. So 0 to 127 means what is the overall ranges? 0 0 0 0 to 127, 255, 255, 255. So these all are class A. Okay, in between that how many numbers it will come? Those all the numbers it will come around class A ranges. So each and every partition they are having 8 bits. So this partition is 8 bit, and this is also 8 bit, and this is also 8 bit, and the last one this is also 8 bit. So totally we are having 32 bit ranges. Okay, so class A ranges is 0 to 127. So each ranges separately I wrote here. So 0 to 0 to 0 0 to 127.255 255 255. This is the class A ranges. Next one is the class B. So class B, what is the range? Overall ranges 128 to 191. That same format we are going to follow here. So 128.020 to 191, 255, 255, 255. This is the overall ranges of class B. Next one is the class C. Class C overall ranges is 192 to 223. That 192.0.0.02, 223.255, 255, 255. And class D overall ranges is 224 to 239. So here we are going to start with 224.0.0.0 to 239.255.255.255. At class E ranges 240 to 0 0 0 to 255.255.255.255. So this is the overall ranges of each and every classes. So class A ranges starts from 0 and end from 127. Class B start from 128, it's going to end on 191. Class C start from 192, it's going to end on 233. Class D starts from 224, it's going to end on 239. And Class E starts from 240, it's going to end on 255. Next one is Class A. So already I explained, so they are having 4 partitions. But here, how many partition is you going to use net ID and how many partition is going to used in host ID? We should know about those. Then only we are going to calculate how many networks we are connected under the Class A. How many devices we are going to connected under the Class A ranges. So here we are going to create network ID and host ID in class ranges itself. See, in Class A, so 4 partition already we know about that. So one is the net ID, first 8 bit, that is called an net ID, remaining all 3 bit is a host ID. Remaining all 3 bit is a host ID. Okay, so only 1 bit, that one is the net ID. So what is the overall ranges? Net ID means 0 to 7, 8 bits. Okay, 2 power 7. So what about here? 3 partition, 8 plus 8 plus 8. So overall 24. So like that. So overall network, how many networks we are going to create it here means 128 networks we are going to create in Class A ranges. Remaining 2 power 24 devices, which means 2 power 24 means it will come around 19 billion. Okay, that much systems we are going to connected under the host ID in Class A ranges. This is the Class A ranges net ID host ID. Okay, so clearly I will write here net ID, host ID, host ID, host ID. So here 8 bit only net ID, remaining all 24 bit is the host ID in Class A ranges. Next one is the Class B. So net ID is 16 bit, which means 2 partition is allocated for net ID and remaining 2 partition only is going to allocated for host ID. Host ID. Okay, so this is the 16 bit and this one is the 16 bit. Okay, 2 power 16 network ID we are going to create it here, and 2 power 16 host ID we are going to create it here. So that is called an Class B ranges. And next one is the Class C ranges. Class C, 3 partition is allotted for net ID. Net ID, net ID, host ID. Okay, so here 24 bit is going to allocated for net ID, remaining only 1 partition is going to allocated for host ID. Okay, but next one is all 4 partition is allocated for net ID. Class D ranges, all 4 partition is going to allocated for net ID. Net ID, net ID, net ID, net ID. Okay, this is the Class D ranges. And Class E, they don't have any other net ID and host ID and all. So that one is the default. No net ID and no more host ID. That one is the Class E ranges. Okay, Class A totally we are having only 8 bit of net ID, remaining 24 bit is host ID. Class B only 16 bit, 2 partition is allotted for net ID, 2 partition is allotted for host ID. And then Class C is 3 partition is going to allotted for net ID and only 1 partition is going to allotted for host ID. And remaining Class D is there. Class D, all partition is going to allotted for only net ID. And the next one is Class E. Class E, they don't have net ID and host ID and all. Okay, so this is the overall basic objective of IP address. So I explained here IP address, objective and types of IP address. Now we are going to discuss about IP related problems. Okay. Now in IP related they were asking so many problems. Now we will discuss about what are the problems. Okay, first separately they will give some partitions number. For partitions decimals number they will give. So with using the decimal number, you have to find what is the class ranges, what is the class type, we have to find it. Okay, so that is the one problem. And next one is simply they will give some decimal value, automatically want to convert it to the binary, decimal to binary notation. And third problem is binary to decimal notation. So these three type of problems we are going to discuss right now. So first I will give some values. For example, 1112, this is the first problem, 1112, 98, 22, 01. Okay, so this is the value, they will, this is the value it's given. So 112, 98, 22, 01. So in question itself they are mentioning. So here 4 partition is there. So 4 partition is there means this is the IP address class ranges. First you want to find it. In case they will give more than 256 means that one is the wrong IP address. So already we know about the ranges. So each and every classes ranges I wrote it here. So here itself you will check, and after that you will write the class ranges. Okay, so 112.98.22.01, this is the overall decimal value. Now you will check the class types. So how you are going to check it? First you will check the first partition. First partition number is here 112. So 112 means what is the first ranges? 0 to 127. So this is the ranges of class A. In between that only that number is there. 112 means 0 to 127. So this one is the class A ranges. Okay. Then next problem, 254.222.25.223. So this is the another one problem. Okay. In this problem just you will find what is the class type. So 254 means just you will check the ranges 242 to 255. In between that number is there 254, in between it will come around the class E ranges. So automatically you will find the class E. This is the class E type. Okay, I will give another one number, just you will tell the class ranges. So 272.212.300.24. What is the class ranges type? So 272, but we know class E ranges up to 255 only we are having the ranges. 272 means this is the no IP address. Okay, so in between that 0 to 255 only it's having IP address. So apart that number it will come means that is not an IP ranges and all. Okay, so like this method they were asking so many problems. So simply they will give the decimal values and then you have to find that class addresses or class types. So now next one is the second problem. Second problem means that same number I taken here 112.98.22.01. So now I am going to convert, this one is the binary notation. Okay, decimal number to binary notations. So you want to convert this number to decimal to binary. Okay. So first you will write here how many bits is already I told you. So each partition they were having 8 bit. So now you will write that 8 bit ranges 1, 2, 4, 8, 16, 32, 128, 64, 32, 16, 8, 4, 2, 1. So totally 8 bit, right? So 8 bit I wrote that number. So first one is the 112. 112, which one is the nearest to 112? 64 is the nearest to 112. Okay, in that nearest value just you will mark 1. Binary number means zeros and 1 only. 64. So remaining how many value you want to add here? 64, 112. 64 means 36, 46. Remaining 48 is there. 48, which one is the nearest to 48? 32. So you will mark 1 here. 32 means what about remaining 8 to 8, 16. So 16, here you will mark 1. So remaining all the bits you will mark 0. Okay. So this is the binary value for 112. So you will write here 0, 1, 1, 1, 0, 0, 0, 0. This is the binary value for 112. And next one is 98. 98. Which one is the nearest to 98? 64. So in that place you will mark 1. What about remaining 98 minus 64? 4, 3. Remaining 34 is there. Which one is the nearest to 34? 32. So remaining 2. So in that 2 place just you will mark 1. So remaining all the bit is 0. Okay, this is the binary value for 98. So just you will mark it here 0, 1, 1, 0, 0, 0, 0. Every time just you will check that 8 bit is there or not. Okay. So 1, 2, 3, 4, 5, 6, 7. 1, 0. So this is the 98 value. What about next one? 22 ranges. 22, which one is the nearest to 22? 16. In that place you will mark 1. What about remaining? 4. And one more 2. So remaining all the bit you will mark 0. So in this 22 binary value is 0, 0, 0, 1, 0, 1, 1, 0. What about 1, 0, 1? So 0, 1 means here only you will mark 1, remaining all the bit is 0. So 7, 0, 5, 6, 7, 1. So this is the binary value for this IP address. 112 is an IP address, that is the decimal number that you want to convert to the binary notation, decimal to binary notation. This type of problems also they will ask. So another one is the third problem. Third problem, some binary value they will give. So with that binary value, you have to find that decimal numbers. So I will write that binary value. Sorry. So now I will write the binary values here. 1, 1, 1, 0, 0, 0, 0, 0 is to 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Okay, so this is the binary value. Question itself they will given. So now you want to find what is the decimal value of IP address. Okay, decimal value. You want to convert this value to binary value to decimal value. Now how many bits is there? 0. First bit is the 0. Second, third, fourth bit only 1. So second, third, fourth bit only they are having 1. Okay. Okay. So here itself you will count it here. So 0, 1, 1, 0. In here bitwise they were mentioning here. So first bit is 0, second bit is 1, third bit is 1 and fourth bit is 1. So wherever you are putting 1, just you will count that value. 64 plus 32, 96, 96 plus 16, 106, 112. Okay, 112. And next one. So 1, 2, 3, 4, 5, 6. 6 bit they are having 0. 1, 2, 3, 4, 5, 6. 6 bits they are having 0. Remaining 2 bit is a 1. So now wherever you are putting 1, just you will count that value. So 2 plus 1, 3. So this is the ranges of 3. And next one is same thing. First 3 bit is 0. 1, 2, 3. Next 3 bit is a 1. 1, 2, 3. Remaining 2 bit is 0. So already told you 16, 8, 24 plus 4, 28. And next fourth one is all 5 bit is 0, last 3 bit only 1. Now you will count the value 6, 7. Okay. So this is the decimal notation. So already question itself they are giving the binary notation. You want to convert that decimal notation. Now you will find that types of classes. Okay. So 112. 112 means everyone know about 112. This is the ranges 0 to 127 means all default it will come around class A ranges. So this is the type of class A. Okay. So this is the 3 problems we discussed here. One is some decimal values they will give, you want to find the types of classes, and the second problem is separately they will give some decimal value, you want to convert to the binary notation, and third problem is they will give binary values, you want to convert to decimal notation. So this is the 3 problems we discussed. So next one is the subnet mask problems. Okay. Next one is the fourth problem. So fourth problem, find net ID and host ID. So some value they will give. So you have to find what is the net ID for this IP address and what is the host ID, exact host ID numbers. Okay. Host ID, this is the host ID actually. So in this host ID, you have to find net ID for this IP number. Okay. So first you will check the value 1 is to 22 is to 200 is to 100. First you want to find the class types. So 1 means what is the ranges here? 0 to 127. In between that value will come. So automatically this is the class A ranges. Class A type. Okay. So class A type means already we explained. So totally 4 partition is there. Class A they are having only one net ID partition. Remaining 3 partition is host ID. Then only one partition is a net ID. Remaining all 4 partition is a host ID. So then what you are going to do means net ID itself, just you will write whatever number in net ID, just you will write that number 1. So remaining 4 partition you will segregate it here. So remaining these all are the host ID number. Okay, already we discussed. Class A they are having only one net ID, remaining 3 partition is a host ID, means only one partition net ID. Net ID number just you will write it here. Remaining all the thing is a host ID, just you will mark 0. 1, 2, 3, 4. Okay. So this is the net ID for this IP value. Okay. This is the net ID for this IP address. Then next we will take another one value. 190 is to 13 is to 10 is to 10. Now first of all you want to check the class type ranges. 190 means automatically it will come around class B ranges, because class B is 128 to 191. In question itself they are having only 190. 190 means this is the class B ranges. Okay. So class B means automatically we are having 2 partitions they are going to allocate for net ID and 2 partitions they are going to allocate for host ID. So then this 2 partition is a net ID and this 2 partition is a host ID. So I already told in previous problem. So net ID numbers you have to default, you have to write it the same number. 190 is to 13. So 2 partitions they are having host value, right? So in that host value you will mark 0, because we are going to find only the net ID. Okay. So this is the net ID for this IP address. So in question itself they will give only one decimal number. With using the decimal number, first you want to find the class type, then only you are going to find, easily understand how many net ID and how many host ID is going to allocate for that class ranges. With using that easily you will find the net ID. Okay. Next problem is third one, 201.2.4.2. Just you will check this value 201. 201 it will come around the class C ranges. In class C ranges already we discussed, class C they are having 3 partition is allotted for net ID and only one partition is going to allotted for host ID, right? This 3 partition is allotted for net ID, and this one is only one partition is going to be allotted for host ID. Now what you want to do? Just net ID numbers automatically you have to write it. This is the class C. So same value 201 2.4.0. So this is the net ID for this IP address. Like this method only, you have to find that IP address, some IP value they will give, you have to find that net ID. Okay. So this is all our host ID only. And question itself they are giving host ID values. With using that host ID value, you want to find that class ranges. After that, you have to find that net ID. Okay. That same concept, using the same concept, you have to find that subnet mask. So what is the subnet mask? So now I am going to explain about that subnet mask. Subnet mask means with using that subnet mask, you are going to identify the net ID. With using that subnet mask only, you are going to identify the net ID. Already we discussed class A ranges only one partition. Wherever net ID is there, in that place you have to mention 255, value of 255. Okay. So this is that 255, remaining 0, 0, 0, because only one partition they are having net ID. Remaining all partition is host ID, sorry. So that's why we are putting 255. Net ID means just you will mark 255. That same thing class B. Class B, 2 partition is having net ID, so you are going to mark 255. 255 0.0. So this is the subnet mask value for class B ranges. And what about class C ranges? Here in class C ranges they are having 3 partitions they are going to allotted for net ID, only one partition is going to allotted for host ID. So that's why we are going to mark it 255 255.0. So this is the subnet mask value. So why we are going to use this subnet mask? Subnet mask, with using this subnet mask only you are going to identify the net ID. Okay. So now in the subnet mask they are having 2 partitions. One is the boundary level partition and another one is the non-boundary level partitions. In that boundary level partitions, in boundary level partitions lot of problems they will ask. That same time in non-boundary level also they will ask separate problems. So boundary level means ranges. In subnet mask, 2 ranges, boundary level and non-boundary level. Okay. In that boundary level 0 and 255. This is the ranges of boundary level. At the same time in non-boundary level they are having in between that 0 to 255, whatever the number there, that is the ranges for non-boundary level. Okay. Boundary level means 0 and 255. In case only it will come 0 or otherwise it will come 255. Okay. But in non-boundary level, in between that 0 to 255, that value, whatever value it will come, that is called a non-boundary level value. So this is the non-boundary level values. Okay. So now we will discuss about non-boundary level and boundary level problems. Okay, one by one we will discuss. So that is the last topic of this unit.